Previously, we calculated freezing point depression. Next, we'll calculate boiling point elevation, which is calculated similarly, except the boiling point is elevated, so we just add the change in temperature instead of subtracting it. What mass of ethylene glycol in grams must be added to 1 kilogram of water to produce a solution that boils at 105 degrees C? So we want to change the boiling point. Our delta T, B, is equal to 5.0 degrees C. Okay? And we know that we have 1 kilogram of water. We need to find the mass of the ethylene glycol. The delta T is equal to the mole concentration times the K sub B. So from the change in boiling point which we were given, we can calculate the molarity. Okay, so because we know the K sub B for water. Now, once we get the molarity, we can calculate the moles. So we're going to convert kilograms of water to moles of ethylene glycol to grams of ethylene glycol. Alright, so let's go ahead and get started. Our delta TB is equal to the mole concentration times the K sub B. So the mole concentration is equal to delta TB over KB, which is 5.0 degrees C divided by 0.512 degrees C per mole. That's the KB for water. Okay, so the mole concentration is 9.77 mole. Now, we had 1 kilogram of water, and we learned that the molality is 9.77 moles per kilogram water, moles of ethylene glycol per kilogram water. Alright, and now the molecular weight is 62.07 grams per mole, and that gives us 6.1 times 10 to the second grams of ethylene glycol. And we put it in scientific notation just to avoid ambiguity, because this would be 610 grams of ethylene glycol, and we don't know where the uncertainty lies in this number. So by putting it in scientific notation, we can remove any ambiguity and get the correct number of significant figures. Next, we'll work for practice 14.9 for boiling point elevation. For practice 14.9 says, calculate the boiling point of a 3.60 mole aqueous sucrose solution. Again, this is a non-ionic solution. So the change in boiling point is equal to the mole concentration times K sub B for water, which is equal to 3.60 times 0.512 degrees C per mole. So that was 3.60 mole. Alright, mole cancels and we get 1.84 degrees C. So the normal boiling point for water is 100 degrees C. So we add the TB to that because we're elevating the boiling point, and that's equal to 101.84 degrees C.